Welcome to electrical machine lecture. Today we will discuss the testing of DC machine and some sort of the calculation based on the direct load test. So in the testing of DC machine, there are two methods. First is the direct load test. It is called as a brake test. In this test, the motor is directly loaded at actual loading. And second is the indirect test. Indirect test, there are some methods like Swinburne test, it is a no load test. Hopkinson test, it is a back to back test, or it is called as a regenerative test, because in this case, two machines are used, one acting as a generator and second acting as a motor. Field test, it is used only for the DC series motor. For the mechanical arrangement, for the mechanical load over the DC motor, uh, such type of mechanical arrangement is carried out. These are the two spring balance S1 and S2, which will measure the load in kg. It is connected with the some belt. It may be a leather belt or it may be a canvas belt over the pulley. So this is the pulley of motor whose diameter is R, and this is the entire motor. So the tension on the pulley is going to increase with the help of this adjustable, say, steerings over the mechanical arrangement. So by increasing the tension, it will increase the load over the motor. So this is the actual picture. It shows here these are the two wheels are there by for loading of the motor. This is the canvas belt. It is over the drum. So the drum diameter or it may be the radius is easily calculated. And these are the two spring balance which will measure the load in kg. So this is method. The direct load method is can be used for any type of motor. It may be a DC motor, AC motor. Again, in case of DC motor, the motor may be a DC compound motor, DC shunt motor, DC series motor. For our simplicity, we have taken the example for the DC shunt motor. It is connected with the direct load. So this is the starter where L is connected to the line through the ammeter, which will measure the current drawn by motor, the DC ammeter. The voltage across motor or the voltage applied to the motor is V. Now F point is connected to the field winding and A is connected to the armature. So this is the DC shunt motor. It is mechanically coupled. This symbol is represent the mechanical coupling over the spring balance, or there is a drum, and over the drum this belt is there, and over the belt is connected with the help of it is connected through the spring to measure the load in kg. So this is brake drum, this is motor entire, it is seen. So here the DC shunt motor is going to test under direct load test is going to conduct over the DC shunt motor. Now this DC shunt motor can be replaced by the DC series motor, compound motor, like this. So whereas the method is same. Now procedure, first of all, run the motor at the rated voltage at rated speed at no load condition, whatever the rated speed is given on the nameplate. The nameplate reading is always the rated value, like applied voltage, rated current, the current drawn by motor at full load condition, what is the power output, either it is mentioned in the kilowatt or HP, what is the rated speed, and so on. A type of insulation, class A, class C insulations are there. Many parameters are written. So second point is that load the motor by mechanical loading arrangement and note the reading of spring balance S1 and S2. So after loading the uh, motor with the help of this mechanical arrangement, correspondingly, we have to measure the load in kg S1 and S2, which is going to measure in kg S1 and S2. Speed and power drawn by motor. What is the speed under load condition? Because during the load, the speed may fall with a small value or it may be higher value as per the type of motor. Voltage and current in steps till for full load condition. So we have to load the motor from a no load condition to its the full load value. As the motor is loaded, motor draws more current and speed drops. So these are the some observed value. or we have to observe during this test. So the supplied voltage, initially the rated voltage, current at no load condition is very small, hardly 5 to 8%. Now speed is the rated speed or no load speed, say for example is a 1500 RPM, and spring balance is 0 at the no load condition. But as soon as we increase the load, it will read S1 value and S2 value. So under such condition, the speed start dropping, and whereas the current also increases with increase in load. So these are the some of the readings we have to take. It may be a 4 or 5 readings or till it's a full load value. Now calculation. Let we consider the R is the radius of pulley in meter, where S1 and S2 is the spring balance in kg. The spring balance which is connected, it measured the load in kg. Speed in RPM, the motor speed in RPM. V is the applied voltage, and I is the current drawn by motor. So these are the parameter already we have mentioned in the observation table. Now the total load on the motor is nothing but S1 minus S2. It is measured in kg. Therefore, the shaft load, we know that the torque which is equal to the force multiplied by the distance. So S1, S2 is the force which is measured in kg and R in the meter. So the shaft torque is S1 minus S2 into R. So where is R? So see in the diagram, this is the value of R. Okay, this is the radius, and the load S1 and S2, it is measured in kg. So the force multiplied by the radius is nothing, force multiplied by the distance is nothing but the torque. So here it is possible to calculate the torque in kg meter because load in kg. Now convert torque kg into Newton meter. So S1 minus S2 multiplied by the resistance R into 9.81. So it comes into the Newton meter. Now power output from the basic equation of the mechanics, shaft torque multiplied by the speed. So here the shaft torque is TSH and speed is the angular velocity is omega. So torque multiplied by the angular velocity is nothing but the power output of the motor. Now as the torque is S1 minus S2 into radius into 9.81. So this much is the power output. This much is the torque, shaft torque multiplied by omega. So this is nothing but the motor output in watt. Now motor input is nothing but the current drawn by motor multiplied by the voltage. So power input is equal to V into I, it is in watt. So now the output we know, shaft torque we know, input we know. So it is easy to calculate efficiency. So output power divided by input power multiplied by 100 is the percentage efficiency. Similarly, uh, percentage speed regulation can be calculated, which is nothing but the percentage change in speed with respect to the load. So here the no load speed minus load speed divided by no load speed. So at any particular speed, at any particular load condition, it is possible to calculate the efficiency as well as the speed regulation. So once all these parameters observations are available, all these calculations are available, it is possible to tabulate the calculated value. So the calculated value is nothing but the power input to the motor, load on the motor, which is in kg, or it is in Newton. Uh, Newton. Similarly, the speed at no load condition, the speed will be higher, say 1500 RPM. And as the load increases, it may be a 1480, 1470, 1460, like that one. Since the DC shunt motor, roughly the speed is somewhat constant. Now, shaft torque, it is possible to calculate at each load condition, at each load steps also. Now, similarly, the power output, efficiency, and speed regulation. So once these calculated values are available, it is possible to draw the say performance characteristic of motor. It may be any type of DC series, compound, or shunt motor. Now, what are the advantage of this method? Since this method is directly load over the motor, so definitely this method is applicable only for the small capacity machine or small capacity motor, because it requires a large amount of power. It is the as per the rated capacity of the motor. Similarly, it requires the mechanical load. So this test requires no other machine. First point is that it does not require any other machines. Only the machine is used which is under the test. Therefore, the cost and energy will be small. But this method is very simple, very much convenient for small DC machines, not for the higher capacity motors. Since this, so therefore, this motor is used only for the this method is used for the small capacity machine. Second, the efficiency can be determined under any actual load condition from no load to full load. So if you want to calculate the efficiency, torque and all things, all parameters at 50%, now load the motor up to the 50%. Say for example, the motor load is 15 ampere. So load the motor up to the 7.5 or 8 ampere. If you want to know the performance at full load condition, so then load the motor till, means load the mechanical arrangement till it will draws up to the full load current. Now, one more advantage is that as the motor is under load condition, actual load condition, therefore the mechanical vibrations, sparking over the brushes, that is called as a commutation, and temperature rise can be accounted. Since it is directly loaded, therefore it will increase the temperature of motor, working temperature. Similarly, vibrations are there, bearing sounds are there. It may be some sparking, because sparking is going to occur at the higher load condition. Therefore, these parameters also accounted by this method. Now, it has some disadvantage. The very first disadvantage is that this test is performed on a small motor only. So big motor requires a large power, large mechanical arrangement, say 10 HP, 15 HP, it's okay. But if you want to conduct the 50 HP, 200 HP or 100 HP motor, it is difficult to conduct direct load test over the motor. Second, it is difficult to dissipate the large amount of heat generated at the brake, because there is a continuous say rubbing or friction between the belt and drum. Therefore, heat is going to generate. The drawback of brake test is we cannot determine unavoidable error occurred in the spring balance. So spring balance may lead the error, because it is not going to, it is continuous in vibration. So it is possible that it does not read the correct value. So this is one drawback. While performing the brake test on the series motor, it is only for the series motor, because at no load condition, the speed of the DC series motor continuously increasing. So we have to take the precaution that if you do the, if you would say conduct the practical over the DC series motor, it is necessary to put some of the load and then we have to start the DC series motor. So this is the disadvantage of this method. Now we will do some of the numericals. Now this numerical is like that. Following readings are obtained when doing load test on DC shunt motor using brake drum. Means it is a direct loading. Spring balance reading 10 kg and 35 kg. Speed is 950 RPM. Diameter of drum 40 centimeter. Applied voltage is 200 volt. Line current 30 ampere. Calculate the power output and efficiency. So it is very simple. Here S1, say S1 is equal to 35 kg, S2 is equal to 10 kg, because we want S1 minus S2 should be a positive value. Load will not be a negative. Then speed of the motor, it is given in RPM, 950 RPM, and diameter of pulley D is equal to 40 centimeter. Hence, we can say that radius R is equal to 20 centimeter, whereas the applied voltage is 200 volt and current drawn by motor is 30 ampere. Okay, so for that purpose, first we will calculate the load on the motor that is nothing but the force. So which is equal to S1 minus S2. It is equal to 35 minus 10 is equal to 25 kg. Okay. Now radius we know, therefore it is possible to calculate shaft torque TSH equals to force multiplied by radius. So now force in kg. So we are going to convert into the, okay, first we will write one more 25 multiplied by radius. It is 20 into 10 raised to minus 2. It is converted into the meter. So it is 20 into 10 raised to minus 2. It is in meter. It is in kg meter. So to convert kg meter into the 9.81 into 25 into 20 into 10 raised to minus 3, it is in Newton meter. So this is the shaft torque. It is available in Newton meter. So it is equal to TSH is equal to 49 Newton meter. Okay. Now power output P out is equal to TSH into omega, where omega is the angular velocity. So it is equal to TSH into twice pi n upon 60, as speed is given in RPM. So P out, output power, is equal to, if you put the values, the output power is 49 into twice pi into, if speed is equal to 950 RPM divided by 60. So P out is equal to 4876 watt. This is the power out. Now power input, PIN is equal to V into I. So 230, voltage is 200 multiplied by 30. It is equal to 6000 watt. Now we know the power output and power this, therefore the efficiency is equal to 4876 watt is the output divided by 6000 into 100. So efficiency of motor is equal to 81.3%. So this is the first one. Now the second, in brake test on the DC shunt motor, the tensions on the two sides of the brake were 2.9 and 0.17 kg. So here S1 is equal to 2.9 kg, S2 is equal to 0.17 kg. Radius of pulley R is equal to 7 centimeter. 7 into 10 raised to minus 2, it is in meter. Current I is equal to 2 ampere and voltage V is equal to 230 volt. Okay. Now where the speed is given, it is 1500 RPM. So now the speed is 1500 RPM. The motor speed, okay, find the torque, power output and efficiency. So now force on pulley, it is S1 minus S2, it is in kg. So it is 2.9 minus 0.17, it is equal to 2.73 kg. Now force on pulley 2.73 into 9.81, it is in Newton. So it is equal to 26.78 Newton. This is the force. Once we know the force, we can calculate the torque. So torque, TSH, it is a shaft torque. It is force multiplied by the radius. So it is equal to 26.78 multiplied by 7 into 10 raised to minus 2. So it is equal to 1.8746 Newton meter. So this is the shaft torque. So first part is over. Now power output. P out is equal to shaft torque into angular velocity. So it is equal to 1.8746 into 2 pi into 1500 RPM, as it is omega in the radian per second. So it is 60. So it is 294 watt. This is the power output. So it is a P out. Now power input. PIN is equal to voltage is 230 multiplied by current 2. So here this much is the power input. Now efficiency. Efficiency is equal to 294 divided by 460 into 100. So efficiency of motor at this particular load is 63.9%. So in this way, the direct load test can be performed, and it is best for a small capacity motor since the reading or the value of performance characteristic or performance evaluation is at actual. So thank you for this lecture. Next time we will see the indirect method of testing for the DC motors.